Happy Halloween, everybody. It's October. We're loving life. This is a geometry section on parallel lines and transversals. We're starting 3.2 today. I just love this ghost and wanted to show them off. Okay, so let's go ahead and jump to one last look. 3, 2, 1. You liked it? Okay, moving on to 3.2. We finished 3.1. We're talking about transversals. So now we are going to move on to properties of parallel lines with transversals. Now, the first thing, obviously, we need to make sure we have parallel lines here. In this case, we do. How do we know? We have parallel indication, those little carrots, as I like to call them. That's Boo, for those that don't know Mario, okay? We talked about this last time. We have kind of two different areas of parallel lines with the transversal. Let me review what the transversal is. The transversal is this line right here. Okay, it transverses two different lines, two or more lines. Okay, I kind of want it highlighted still. Okay. Now, one thing to consider is we want to know if it's on the same side or the other side of a transversal. Well, there it goes. What do you know? So that's something to keep in mind as we do these types of problems. Okay, so I'm going to erase this, because that's what you're going to see. You're not going to have that. I'll leave the interior exterior up there. But we're going to talk about these angle relationships and how all these angles relate to each other. Okay, so we have same side interior angles postulate. Let's talk about that, what that means. So same side, that means the same side of the transversal. So if we have this transversal here, we're talking about the same side of it, okay? So either the left side or the right side, okay? Now, if we're talking about alternate, same side, interior. Okay, that's the other thing. So now we're talking about interior angles. We're talking about the interior space. So the interior space. So same side of the transversal. This is of the transversal. I talked about this in the other video too, but I just wanted to review. Same side of the transversal, and then we're talking about the interior space. So I actually kind of want this back up. I erased it, but I kind of want it. So let me get this going. Okay, my previous job wasn't very good though, so maybe that's why I wanted to erase it. Okay, that's much better. And actually, I'm deciding to erase the transversal. You guys see where the transversal is? I'll leave it up for now. Maybe later I'll erase it. Okay. So we're talking about same side, interior angles postulate. Now, that means that we're talking about, for example, 4 and 5. They are on the same side of the transversal, and they are interior angles. Okay. So 4 and 5, and then 3 and 6. We talked about that last video, but now we're talking about how they add up to 180 degrees. Okay. So 180 degrees, they add up to, that's an ugly 0. That's the same side interior angles postulate. I'm going to go through all these postulates and theorems real fast, and then you will see that we're going to apply it after we talk about it. So alternate interior angles theorem. Again, alternate interior. So they're on opposite sides of this transversal. So if we're talking about here, then we're talking about the other side. But we're not talking about, for example, 5 and 6, because those are supplementary angles. Okay. That's its own relationship, so we're not going to intrude on that relationship. So in this case, we're talking about angle 5 and angle 3 are alternate interior. They're the same color, but one thing you'll notice is they're also congruent angles. That's important. They are congruent angles. They are equal to each other. If 5 is 40 degrees, then 3 is also 40 degrees. If 4 is, what does it look like, 120, then angle 6 is 120, okay? So that's something important to keep in mind, alternate interior. So we're done with our interior space. Let's move on to some other space here. I'm going to do alternate exterior angles first. So alternate exterior angles theorem, we're talking about this space over here. So I'm going to go ahead and highlight it. Okay, so we're talking about this space as I unwisely had it off screen. Oh, not bad. Okay, so we're talking about the exterior space. This is much nicer. Much nicer. Staying inside the lines, doing a great job there. Okay, very important to color appropriately. So exterior space, we're talking about the green area, and we're talking about alternate exterior. So one on one side of the transversal, and then one on the other side. So 7 and 2, and then 1 and 8. Okay, we're not talking about 1 and Oh, 7 and 2, 1 and 8. I thought I had messed up saying that. So we're not talking about 7 and 8 because those are supplementary angles. We're talking about alternate exterior on like opposite sides. Okay, so what do we know about this? Well, look at the angles, how they're obtuse and acute. 1 is going to be equal to 8. You can see it's color-coded. 1 and 8 are the same. They're congruent. And then 2 and 7, they're both obtuse. They are congruent. Lastly, corresponding angles. Corresponding, when we're talking about corresponding, I like to think of it as here's our intersection. We have two intersections that are identical. Okay? The angles in each part of the intersection are going to be identical. So right here, this is the top right part of the intersection. That is the top right. So 2 and 6 are both in the top right portion of the intersection. They are congruent. Let's go to the next one. So if we're talking about angle 1 now, angle 1 is in that part of the intersection. So is angle 5. It's in the top left. So angle 1 and 5 are congruent. Okay, and this same principle applies to all of them. I'm just going to keep using different colors so you can see. Angle 7 and angle 4 are both in the bottom left part of that intersection. So angle 4 and 7 are congruent. And then lastly, we have 8 and 3. So 8 and 3 are both part of, which color should I use? Purple. Okay, 8 and 3 are both in the bottom right portion. So 3 is congruent to 8. That's pretty much it. The one thing I wanted to mention that's really important is when we have parallel lines in a transversal, we're only going to have 2 angle values. Okay, for example, let's say 1 equals, and let's just keep it simple, 40 degrees. Actually, let's change it. I'm going to make it 30 degrees. Yeah, I'm going to make it 50. Sorry, I was indecisive. So let's say angle 1 is 50 degrees. We can find all 8 of these angles, okay, because these two intersections cause 8 angles to be created. We can find all these angles just from that 50 degrees. So all we need is 1 angle. We only need 1 angle to solve for all these. Okay, how do I do that? Well, I know 1 and 2 are supplementary, so I can easily find 2 to be 130 degrees. And then from there, I'm good. Okay, I know 2 and 6 are corresponding angles. I know 6 is 130 degrees. I know 2 and 7 are alternate exterior angles. I know that 7 is also 130 degrees. I know 2 and 4 are vertical angles, or that 7 and 4 are corresponding angles. So I know this is 130 degrees. So see how I'm quickly finding all these angles? So look, 4 and 5. I know these are same side interior angles. They need to add up to 180. I do 180 minus 130, and I get 50 degrees. So this is 50 degrees right here. I know 3 and 5 are alternate interior angles, so that needs to be the same angle. I know 4 and 6 are the same. Oh, I already wrote it down. Are the same. Also, I know that 1 and 3 are vertical angles, so 1 needs to be equal to that one. Lastly, we have this, and there's all different numbers we could use for 8. We could say it's supplementary to 6. We could say it's vertical to 5. We could say it's corresponding to 3. Either way, it's 50 degrees. So it's like a little puzzle. It's almost like Sudoku. Once we have 1 angle, we can find all the rest of those 8 angles, okay? Thank you so much for watching 3.2. Stay tuned for next time when we talk about 3.3.